Large language model chatbots are revolutionizing the application of artificial intelligence in our everyday lives. These LLMs are trained on general knowledge. The real value from chatbots will come when individual organizations layer their own corpus of data on top of standard LLMs and then use the resulting chatbot to support customers and staff. At CloudCIX, we specialize in developing commercial scale chatbots precisely to do just that. This tutorial demonstrates the basic concepts involved in building such a custom chatbot using any general purpose LLM as a base. The strategy we will adopt is referred to as prompt engineering. In prompt engineering, you take the domain-specific corpus of data that your organization already has developed and you embed relevant chunks of that data into the prompt that will be sent to the general purpose LLM. The chunks are matched to the question via a vector database. These embeddings are how the general purpose LLM knows data specific to your organization. In this tutorial, we will use a Jupyter Hub notebook installed on a CloudCIX VM to create a simple pipeline that chunks your existing data and then prepares engineered prompts that can be sent on to the LLM of your choice. Let's get to it. We begin by installing and running Jupyter Hub on a CloudCIX virtual machine. Then, leveraging Jupyter Hub, we will build our own chatbot utilizing the GPT-3 LLM. This powerful language model will efficiently retrieve precise answers from data embedded from URLs. In this tutorial, it is assumed that you're already familiar with the process of building a virtual machine in CloudCIX. If not, I would recommend watching the Building Your First Project video on the CloudCIX YouTube channel. This will provide you with a step-by-step guide on how to create your first project. Okay, I've just logged into my CloudCIX VM. The specifications for this VM are 8GB of RAM, 500MB of storage, and 4 vCPUs. I'm running Ubuntu 20.04. We need to install the required packages to run our Jupyter Hub. The simplest way to get Jupyter Hub is to install the Little Jupyter Hub, a bare-bones version of the Jupyter Hub software which can be downloaded and installed with a single command. I'll type the following, and remember to change the final admin username to whatever username is applicable to your own VM. In my case, I am using admin as the username for the admin user. This will take about 5 to 10 minutes to install. Okay, looks like it's done. To test, if I go to a browser and search for the public IP address of my VM, I can see I'm prompted for login credentials. The password you use for logging into the VM will be the same as the one you use for signing into Jupyter Hub. The username is whatever you selected when you installed Jupyter Hub. Please note that you must have an inbound firewall rule that opens port AD traffic to your VM to allow reachability to Jupyter Hub. Okay, let's sign into our Jupyter Hub. I'm going to create a new Python 3 notebook and I'll name it tutorial. For this project, I will pip install these Python modules. LangChain is a framework designed to simplify the creation of applications using LLMs. Face is a vector store database that stores the chunks and retrieves the chunks relevant to the prompt coming from the end user. The Face vector store will contain all our data chunks that will be used as embeddings. For demonstration purposes, we will use OpenAI's ChatGPT API. But you could use any other large language model you wish. For example, Falcon is an open source LLM that could be used as an alternative for privacy and confidentiality reasons. The Face vector store will contain all our data in the form of embeddings. Next, we need to add our OpenAPI key. An important point to note here is that you must have your own OpenAI account to have a personal key. I'm going to paste my own API key in here, yours will be different to this. Okay, now we need to input URLs containing the information that we want our chatbot to reproduce. In this example, I have chosen a sample of the community documentation for the CloudCIX platform, which can be accessed from docs.community.cloudcix.com. However, it can be as little as one URL. I will then use the LangChain unstructured URL loader to load data from the URLs provided into our chatbot. Next, I'll add LangChain's character text splitter, which chunks our data into chosen sizes. I'm going to set our chunk size to 1000 characters here. By utilizing this size, we guarantee that we are providing the LLM with smaller data segments. This approach allows us to obtain the information accurately when retrieving it later, all while staying within the attention capacity of the LLM model we are using. Next, we will import the necessary applications for creating and storing embeddings in a Face vector store. After that, I will generate our vector store by utilizing the Face library to store our embeddings. We will serialize our data in this vector store using the pickle module and save it in a file named face_store_openai.pkl. The next piece of code will open and read the file we just created. Next, we will import the question and answering chain from LangChain. This integration will enable us to interact with our LLM using these applications. Next, I'll type LLM equals OpenAI open bracket temperature equals 0, comma, close bracket. This assigns the variable name LLM to our GPT LLM model. By setting the temperature to 0, we ensure that our model's responses are precise and accurate. Increasing the temperature would result in more diverse and creative answers, but in our example, customers would be looking for precise answers. If we wanted our LLM to write some poetry, for instance, we might set a higher temperature. Finally, now we will create an instance for our question and answering chain, where we combine our information retriever and our LLM model. This enables the backend that produces the prompt, including the embeddings that will be sent to the LLM. Okay, now it's time to ask a question and see if our CloudCIX chatbot works. Typing in my question, and I can see it will print the question, answer, and sources with the following commands. Let's press the return key, and we have our answer based on the information obtained from the inputted URLs. The output has been formatted for visualization purposes, where the labels question, answer, and sources will be displayed in red before their respective outputs. If there is no accurate answer, our model will respond with I don't know. And there you have it, a fully functional chatbot that embeds the selected data from the provided URLs and effortlessly responds to your questions. The backend can be connected to any LLM of your choice. All of this is running on a CloudCIX virtual machine, ensuring optimal cost, performance, security, and energy efficiency. Thanks for watching.